150, right, is what we did up here. And we're saying that that was fair. The leftover principle was consistent with that, that that was a fair deal, given that indigo was selling at $10 a unit. And then next month, maybe it's next year, whatever, the market tanks on indigo. The land becomes worthless in terms of indigo, but has an alternative in rice. What's it worth in rice?
110.
110. How much were the farmers hurt by? $40. So if the Brits cut them a check for 40, they'd make them whole. Right? They got 150. They paid 150. It really was only worth 110.
So they're not making the $1 from the indigo anymore?
Yeah, they're switching from, yeah, that's the part where you were missing. So it was an alternative use, so no more indigo, we put it all into rice. Yeah, you're not doing both. Okay, Jonathan, good? Okay. Any other last questions or clarifications? All right, you never know. You could see something like this on the final, so make sure you understand it now so when you review your notes in the future.
Is our final like all the
chapters?
So
let's make sure we do that. It is mostly the last chapters, the second half of the.
So it's not going to be. It's just going to. It's not like.
It's a little bit cumulative because it builds on each other,
yeah,
but it's mostly the last. It's mostly the final chapters.
It's not a complete cumulative.
Right.
Okay.
Yep. So that's the other good thing. Yeah, you have less. You just have to study mostly for the last, but some of the stuff carries over, of course. So So the answer to C is therefore appropriate compensation equals 150 minus 110, 40. All right, let's take a look at this number 6 here. Number 6. All right, you are the economist for Space Z. We wouldn't want to do SpaceX, but maybe it's Elon Musk. A producer of space satellites with total revenue of $246 million per year. The material inputs are imported through a port at the center of a semicircular coastal city, and the output satellites are launched into Earth orbit from the production site. For technical reasons, the firm must locate its production site along the coast. The firm's annual costs in millions are as follows. The cost of materials are $30 at the port, and a 1 mile increase in distance to the port increases material transport costs by $16 each time. Labor cost is this function of the X, 100 plus 144 over X. The cost minimizing location is what? So whenever you see something like cost minimizing or profit maximizing or utility maximizing or something like that, what comes to mind immediately? Marginal cost equals marginal revenue. It's a marginal analysis problem usually, right? So what are the costs? What are the benefits? And so that should be kind of the first thing. So we've got some revenue coming in. So if we start to look at the revenue side, producer of space satellites, $246 million. Material inputs are through this thing. Launch for technical reasons along the coast. The firm's annual costs are as follows. Cost of materials at the port, 1 mile increase from the port. And then we got the labor cost. So how can we minimize cost. And it might not always be marginal revenue, marginal cost, but we should kind of think, it's usually a good thing to think of right off the bat. Still got a leftover type of deal going on as well. thought process at here? See a picture, yeah, picture might be good. You got two competing costs, like are they moving the same direction as you move a mile? There's one going up and one going down. So what's happening to labor cost as I increase the distance to the port? What's happening to labor cost? It's going down, right? So that's one thing to kind of pick apart. As this gets bigger, this gets smaller. So labor cost goes down. What's happening to transportation cost? It's going up. So we kind of got one of those types of things going on here. So you could start to graph that out a little bit and make your own little thing like we did on the, like we had on the test of distance to the port. So we've got x equals distance to the port. And so at 1, you could just do 1 for fun. What would we have for labor divided by 1? 244.
Yeah.
So we'd have 244. And our, so this would be kind of on the labor curve. And then what else we got here? For the material cost, what's that end up being at 1? 46. So it's 16. So the function here would be 30 plus 16x, right? So the material cost, is that what they call it? Cost of materials, yeah. So material cost is equal to 30 plus 16x. And then the labor cost is what was given to us, 100 plus 144 over x. And so let x be 1, we get 144, otherwise we get 46. Not drawing this to scale exactly here. Kind of a fun number to do might be to do it at 10. What happens at 10? So at 10, our material cost kind of shoots up pretty fast, right, to 190. And what can you tell me about the material cost function as far as what it would look like? 30 plus 16x. Slope of 16, so it's a straight line, right? So if we were to graph that out, this would be somewhere at 30, and then it would be a straight line. So our material cost function looks something like that. And then we have our total cost function. At 1 was 46 plus 244 gives us how much? 290. So don't forget we got a total cost function along with that. And then at 10, back to 10 I guess, this was 114.4. So our labor cost at 10 was 114.4. So that one was somewhere in here. And then our total cost would be 290 plus 114.4. So what would that be? 200. So that would be, let's call that 200. So so that'd be 300. 304.4 would be our total cost. 304.4. All right, so we could kind of play around like that, right? And kind of do the similar thing with then we would just pick out the distance that would be the smallest distance. What is it at 2? This is kind of the hunt and peck method here, but what is it at 2?
Which one?
172.
Yeah.
172 total or
No.
Total is 234.
Labor.
234?
Total cost.
So at 2, we get 234. 234 is actually down here on my little not drawn to scale graph, right? Well, that sounds pretty good already, right? What was it at 3? $226, so it's already, this was 234, so it's less at 3?
226.
He had 226 at 3. Did everybody get that? Double check, kind of punch it in. I don't have the answers, by the way, so I'm relying on you guys. So at 3, it's 16 times 3 plus 30, and then it's 144 divided by 3 plus 100. Add them together, and then we get 226. Jacob saying yes. Okay, so 226. What happens at 4? 230, so we're going up. So if we're minimizing cost through a little plug and chug method, we'd want to pick the distance that was the least amount of cost. And this thing just starts to blow up as we go further. We already did 10 and we were up here, right? So the cost function does something like that apparently. Because at 1 we were at 190, so it kind of came down real sharply and up. So 226 was our level at 3?
No. Yeah.
So that would be the cost minimizing location. At the cost minimizing site, what would they be willing to pay? $226. How'd you get it? Huh?
It's just the number they have on the graph, I assume.
Oh, that was the cost though. So we're looking at the site of land cost.
78.
We're back to a leftover principle. 78? 226? Just tell me your math.
It's for land because the other cost is labor cost.
Yes.
So you can use that cost. as
So
well.
we're doing the leftover principle though. Gosh, you guys already
48,
forgot about the leftover
48.
principle. How much?
Should be 48, right?
Give me your math. It's all up there.
246.
246
Minus the 226.
minus the 226. So 20 would be the leftover principle for the cost minimizing site. Remember, and that's the most you're willing to pay. The leftover principle is the maximum amount you would be willing to pay. Of course, you'd like to pay less, but given those numbers, that would be the most that we could pay. So 246 is the revenue. Leftover principle would be 246 minus the 226 is the 20. All right. Well, that's good for that one. We're going to get a little crack into next chapter 11. Get your juices flowing on some more distance stuff. I think this one is with office rent. So that was land rent. And so now what about office rent? Oops. Let me switch over to this. Okay. Do we tend to see big office buildings in downtown areas? Yes. All right. So that's part of what this chapter is going to explore a little bit. You know, why do we see that? So is it expensive or cheap to be in one of those big glass buildings that's 53 stories high? It's expensive, okay? So they're relatively tall, price is high, commercial land to build a skyscraper on is pretty expensive per square foot. That's like the most expensive land down there basically, because you can do that to get the per square foot, it's very high. All right, so this last thing, what is the optimal height of the building? In some cases, it's not about being efficient in financial terms, because some rich person, she comes to town and she says, I'm building the biggest building in the city right now. So it's kind of a non-monetary claim to wanting to have a big building. So that's what the last thing that we'll kind of explore in this chapter. Okay, so what's the pricing going to depend on? We've got the median location stuff under our belts. So first question is, how is the information business different from farming and manufacturing that we've been exploring? So we did Gandhi and farming indigo. We've talked about making stuff and having ships built in a certain place and go out to market. Jacob.
You don't need like huge acres or anything.
Okay, good. So some of the tools that they use are pretty small. We got a telephone and maybe a computer, right? So that could be part of the information business. As a human being, a phone and a computer can probably do a lot of damage instead of big machines and stuff. Carlos?
The fertile thing doesn't matter anymore, like the soil.
Okay, good. The soil doesn't matter. It's more about maybe the quantity of space that we can put these bodies into might matter more. We wanted, I'm kind of glad you brought it up that way, the fertile. What do we want to be fertile for in terms of information in our workers that are pretty much a human mind, a phone, and a computer? What would make the ground more fertile for an information business? Accessibility, good. Like, what do you mean by that? I think I agree with you.
Easy to be. Wi-Fi.
Easy to go, easy to communicate with somebody else, right?
I guess.
So proximity in that makes it more fertile, to use Carlos' word. That's what I was thinking, like to make you more productive as a salesperson. Having an environment that is conducive to that would be important. Okay, so we've got different distances. So CBD is Central Business District. So if we're in downtown Kansas City, right, the basically the central hub, and you can be at different locations. And so they're looking at distances depending on where you're located. At location, you can kind of think of this like what we've been doing with 0, 1, 2, or 3. And the further we're out, we got to make extra trips, is what they're trying to highlight here. So here at the 6, going to the east, going to the west, and then we look at the total travel distance. That can start to look exponential pretty fast. Okay, so that just kind of gives us a feel for how we might be measuring things. We're kind of doing median location stuff here with this. All right, so if we graph that out, here's the blocks from center. So firm D is right in the center. And then as we go to E and C, we move further out, the number of steps that you have to take each time starts to grow. And it's not linear. So it's not the side of a martini glass. So this is the number of blocks for information exchange is what they're modeling. Like you have to kind of distance travel, that it's going to be better to be in closer proximity. As you move further out, it's going to be more costly and it's going to be increasing at an increasing rate. The martini glass was just, you go a mile, it costs you $16, right? You go a mile, it goes $16. Here, the way it maths out, it gives you this exponential growth. All right, knowledge spills and direct cost. So what part of what's driving this is just direct costs with moving back and forth, but having people, as you guys were saying, more together would be the idea of the knowledge spills, right? That we can go out for a drink and talk to people, and so we have the knowledge spillover effect that is also related in there. Okay, so we talked about that. Is everybody all right with what this part is saying? So you go back to the number of steps you're taking the further you're out, and it's kind of like, remember when we had when we weren't in the middle, we had to go back and forth, back and forth, back and forth for each customer. That's what's being modeled here. So it's the same thing. All right. All right, so we mentioned the phone and the computer, but the knowledge spills a lot to do with face-to-face communication as well. So there's the leftover principle, our willingness to pay. WTP is our willingness, maximum willingness to pay, is the leftover principle again. And we're saying, what would we bid for office space without input substitution? We've seen that before in previous models. Input substitution. What would we be not allowing? It says without input substitution. What are we not allowing?
Workers probably have to be a little qualified. You can't just substitute workers if that's the main component of the business.
Okay, so if workers were differentiated, then we would, but we're going to assume they're all equally skilled. They're all little clones of each other. So one is actually substitutable with each other in that way. So it's not so much, but what you're saying is in a sense the idea, but it's based on rents. So again, if wages go up, what does McDonald's do to you? If wages go up, they try to charge some higher price, and what do they do relative to inputs?
Hire less people.
Hire less people and use what instead? You order by your phone, you order at the kiosk, right? That's input substitution. As one becomes more expensive, a real world business is going to substitute one for the other. And for starters anyway, we're not going to allow that. All right, we'll call it there. Good job. So Jonathan, we can just meet whenever. Are you back tomorrow or not till next week?
It's kind of up here about tomorrow.
Okay. Okay. Well, whenever you're back, if you want to go over your test, we can do that.
Yeah, can you hold it up just one more time for me?
We have homework.
No homework. You get a free day. Other than read the chapter, that kind of like no official homework, but look, there you go.
Oh, okay. Yeah, we're good.
Okay.
Thank you.
Yeah. Yeah.
Everybody prove that I did my homework.
Okay, let me stop this thing too. You guys you wanted to go question, just general question, or you need your test back?
I didn't have to. It can be. It's just.
Okay.